case, just let's go through these again and see what we have to come up with. So again, make a 0 on one side. Determine if that 0 is saying negative values or positive values. And so what we did on this first one is this is not a 0 on one side, so we had to bring the 12 over to the left-hand side. All right, now, everyone look over there. Look up there, look up there. Am I looking for, when I sign my number line up, am I looking for positive values or negative values according to this? Looking for positive. Okay, good. So now, if I'm looking for positives, I need to have some numbers that define these intervals in which I'm looking for positives. And that's where you go and now you factor. So I can factor x squared minus x minus 12 very easily. Negative 4 plus 3. Again, these are my zeros. The zeros, and when we get to them with rational inequalities, asymptotes, which are the numbers in the denominator that make 0, these guys help me set up my sign chart. So my sign chart now says we're going to look everything left of negative 3. We're going to look in between negative 3 and 4. And we're going to look to the right of 4. And I'm going to put in some test numbers. And I'm going to see what kind of numbers I get. I don't care about the number part, but I'm caring about which thing. Whether it's positive or negative. That's it. Just want to know if it's positive or negative. Don't need to know the number. All right. Simon, I'm going to have you kick this thing off. So you're going to test for me a negative, what should we pick over here? Okay, now negative 2 is here. Okay, we're going to test a negative 4. All right, we're going to put a negative 4 in here and see what we get. Okay, what do I get? A positive number or a negative? That's all right. What kind of number am I going to get if I plug a negative 4 in for x? How'd you get a positive? Negative 8 times negative 1 is positive 8. This is a positive number. So that means right there are positive solutions. Everything to the left of negative 3 is a positive solution. Okay, Leanne, what am I going to test now? Great idea. Let's test the 0. I put a 0 in for x. What kind of number do I get? I get a negative number. Okay, now we're going to test James. Test 5. All right, we're going to put a 5 in for x. And we get a positive. Does that clear things up with our negative and positives and negatives a little bit? Yeah, but how that should be different. Okay, we haven't found the answer yet. All we've done is we've determined where my positives and my negatives are. Now I got to go back. I got to go back and look at the original that has the 0 on one side. Does that say to find negatives, or does that say to find positives? What does a greater than 0 mean, Evan? What is a greater than 0? I'm looking for positives, so I want to go find those. And here they are. Dun, dun, dun. There are my positives. And therefore, my answer would state, I want everything from negative infinity to negative 3, because that's where positives hang out. Then I'm going to union them, because I've got this gap in between, with 4 to infinity. There's my solution. Make a little more sense? Makes a lot of sense. Okay, that's good. Good. Okay, now we're going to skip to a problem that involves rationals. This is now where I have polynomial on the bottom. And what can't we have in the denominators? Okay, that's true. We can have radicals, but what number can I have? value that gives me a 0, but that thing is not called a 0. It's called a vertical asymptote. I think we touched on this on Friday. You know, we're going to do the one over here onto the right, x plus 1, x minus 3 greater than or equal to 2. Try that one first. I have to make the 0 on one side, move the 2 over. How am I moving the 2 over here? Whoa, careful now, careful. How do I move a chunk from one side to the other side? I either add or subtract. So I got to subtract this 2. So this is going to become an x plus 1 over an x minus a 3 minus a 2. Ding dong. Okay, here's what I want you to think about. What am I looking for in my sign chart? Positives. Looking for positives in my sign chart. All right, we're ready. Now, I'm not quite done with this problem because I've got a little work to do. I got a fraction on one side, and then I got a whole number. So what do I need to do with this thing? I'm going to have addition or subtraction involving fractions. What do they both have to have? Common denominators. All right, what's my common denominator here? Good, it's x minus 3. That means I'm going to have to take the original problem and leave it alone. But 2 is going to have to multiply by my common denominator on the top and bottom so that I create 2 denominators of x minus 3. All right, got a little work to do. Yes, ma'am? Could I multiply the whole thing by x minus 3? Yes. However, if I do that, I will probably forget that the original started with an x minus 3, which means there is an asymptote value of x that I have to be careful of. So I'm going to say, let's not do that, so that when we set this thing up, we have an x minus 3 in the denominator, and I will then know that when it comes to testing my sign chart, a 3 is not a 0. A 3 is a vertical asymptote for this graph, which means I can't ever be equal to 3. So, yes, I could multiply x minus 3 and then get rid of that x minus 3, but then you'll lose your asymptote. So let's leave it as a fraction. Right, we simplify all this. On the top, I get x plus 1 minus, and I can distribute that 2, minus 2x plus 6, and all of it now is over x minus 3, greater than or equal to 0. Still have some simplifying to do on the top. X minus 2x is negative x plus 7 now, over x minus 3 is greater than or equal to 0. So here's your objective. Your objective is 1, get 0 on one side. Objective number 2, get the other side to be a fraction. One fraction, not 2, not 3, one fraction. And that's what we have. Down here, this is where we're going to find these dudes. Vertical asymptotes. They are numbers that I need. What is that? They are numbers that I need for my sign chart. Up here is where I find zeros. So the numerator is where I find zeros. The denominator is where I find vertical asymptotes. Okay, we set these things negative x plus 7 equals to 0. That means x equals 7 is a 0. Vertical asymptote. X minus 3 equals 0. That means x minus 3 is a vertical asymptote. These are now the numbers that I use in my sign chart. 3 and 7. I use zeros for my sign chart, and I use asymptotes for my sign chart. Vertical asymptotes for my sign chart. So we set up our sign chart, and I have a 3, and I'm going to put a circle around that because I'm reminding myself that that is not a 0, which means if I plug a 3 in for x, I'll not get an answer of 0. I will get an undefined answer. So I can't include this. I can never include asymptotes when it comes to writing out my interval notation. All right, so far so good. Now we're ready to test. So we're going to test to the left of 3, 0. Where do I put it? Well, I'm always plugging it back in to our inequality that we're testing, which is that one right there. So we're going to test 0. And I get a negative 0 plus a 7 over a 0 minus a 3. And that gives me a what? Negative number or a positive number? Huh? That's a negative number. 7 over negative 3 is a negative number. So I get a negative number there. So now we're going to test another number between 3 and 7. Let's test 4. So now I get negative 4 plus 7 over 4 minus 3. And that gives me a positive 3 over a positive 1, which is a positive value. Now we're going to test to the right of 7. Let's test 8. So we now have a negative 8 plus 7 over 8 minus 3. And that gives you a negative 1 over a 5, which is a negative number. And I can see that I'm looking for, in this example, all my positives. So my solution would say everything from 3, but not including 3. Because it is an asymptote. This little bar here means I can include the zeros, but not asymptotes. I need to learn to write. So include 0, but not asymptotes. That's what little bar means. So I circled that 3 to remind myself that is an asymptote. I will not include that in my answer. So my solution would be anything from 3 to 7, where I can include 7 because it is a 0. Those are the answers that would satisfy this inequality. No union because I don't have another plus somewhere else. I just have one single positive value, and I have 2 negative values. All right, we got 5 minutes. We're going to roll as fast as we... Oh, man, we're not going to get this. Hang on, don't give up. Don't give up. Okay, I'm going to pick... Let's see. Let's try this one real quick. Real quick, this third one, x plus 3 over x plus 5 minus x minus 1 over x minus 2. Here we're going to get a little more intervals to work with because I have a couple different vertical asymptote numbers. All right, real quick, here we go. For the sake of time, my LCD is x plus 5 times x minus 2. That means I'm going to set up my original problem, but I'm going to have to multiply by the missing LCD, which is x minus 2 on the top and the bottom. Minus, oh, got to be careful of that negative. Put it in parentheses. And then this one is missing the x plus 5 part of my LCD, so I'm going to have to multiply by x plus 5, x plus 5. I'm looking for positives. All right, we do all of our work, and up in the top would be FOIL. I get x squared plus x minus 6 minus, and I'm going to put in parentheses, the foiling of x minus 1 and x plus 5 gives me x squared plus 4x minus 5, and all of that is over x plus 5 times x minus 2. I do a little combining like terms. X squareds get to cancel. X minus 4x is negative 3x. Negative 6 plus 5 is negative 1. Set up my sign chart. Look at this. 3 different areas now, or 3 different values. I have negative 5 as a asymptote. I have positive 2 as an asymptote. And then I have negative 3x minus 1 equals 0, 3 3x equal negative 1, x equal negative 1/3 has a 0 value. So then I test 4 different areas now. To the left of negative 5, I plug a negative 6 in. I get a 18 minus 1, positive on top, over a negative on the bottom, making negative. If I plug in a negative 4, I get a 12 minus 1, a positive on the top, over a negative on the bottom, another negative area. So here's one where we see we don't alternate the pattern. If I test a 0 now, I get a negative on the top and a negative on the bottom, which is positive. If I test a 3, I get a negative on the top and a positive on the bottom, which is a negative. So look at that. That's a little different than we've seen before. Negative, negative, plus negative. And I want to find all of the positive values. That means I'm looking at that interval right there between negative 1/3 and 2. Negative 1/3 I can include. 2 I cannot because it is an asymptote. So that would be in my set of numbers. All right, I will put the rest of this thing on. You guys can take a peek at it Blackboard-wise or YouTube-wise. Thursday or Friday. See ya. All right, guys, I'm going to be talking to myself here.
Sounds great.
All right, on top, we're going to factor out an x. And set up my sign chart. I'm going to have 2 zeros at x equals 0 and negative 2. I'm going to have vertical asymptote at x equals 3. Move some stuff out of the way. Here. All right, so we have sign chart. Negative 2, 0, 3. Can't be that. So the sum of 2, negative 3 gives you a negative 3 on the top. Sign to negative 1, which is a positive, over a negative. Negative 1 on the top. Giving me a negative over another negative, which is positive. 2 is positive over negative. 4, we get positive. So I'm looking for, in this case, negatives. So all my negatives would be from negative infinity to negative 2. Since 2 is a 0, it's included. Union with 0 to 3. Don't include the 3 because it's an F. There's your solution. When you have radicals, you have denominators and numerators. Again, you can't have negatives underneath the radical. So in this case, this has 2 situations. Can't be 0. And the whole radical can has to be greater than or equal. So what we do is we set up the domain. We have x over x plus 2 must be greater than or equal to 0. And then here we set up our zeros and our vertical asymptotes. And our sign chart. And I can't be negative 2, so we're going to sign, make sure you get that one squared away. So test everything to the left of negative 2. Negative 3. Negative over negative, positive. Test negative 1. And you get a negative over a positive. Next test a 1, you get a positive. I'm looking for all the positive values. Going from negative infinity to negative 2, we don't include it. We're going to union that. 0 to infinity. your inequality is looking for 0. So in the first scenario, if revenues are greater than cost, 5p minus p squared greater than 7 minus p. You get a 0 on the right-hand side. Negative p squared plus 6p minus 7 greater than 0. If I divide everything by -1 to clear my negative p, I switch the direction of that inequality because we divided by base. So we set up our zeros in this case. P, we're not going to come back for this one. So we're going to have to set up Thackeray or quadrat. Negative p minus p squared minus 4 a minus p. Plus minus 1 squared 6 plus or minus 2 over 2. Factor out of 2 out of the top. Cancel. And I get 3 plus 2. Those will be the 0.